Hi guys, today we're going to be taking a look at page 5 of the Unit 11 packet. Once again, that's page 5 of the Unit 11 packet, and we're going to be taking a look at 3D figures and how to classify them, alright? Now, you have the basic classifications written there at the very top, so I'm not going to spend too much time on that. And you guys have already looked at these in both 7th and 8th grade in some detail. But just to make sure you guys remember some of the important bits, let's go back through a few of these, okay? So the most important one to start off with is what's called a prism. Now you guys have heard of prisms before, partly because when you have one of those like triangular prisms that refracts light and you can see all the colors of the rainbow, that's actually a prism, right? But in this case, we're going to be using the geometric definition of a prism. A prism is essentially just when you have a shape. So in this case, let's just say like, I don't know, a rectangle. And I have another shape that's exactly the same, that's a base of the prism. And it's kind of been translated vertically, all right? So in other words, a prism is really just when you have two bases, right? One right on top of the other, and one base has risen, or you could say it's been translated vertically, or in some cases horizontally, to make a prism. Now in this case, it's a rectangular prism because each one of the bases is a rectangle. You can also have different shapes or different types of prisms. For example, a triangular prism. Why do you think this one's called a triangular prism, huh? Well, because it has triangles as its base. By that logic, what do you guys think that this should be called, right? Again, I apologize if this is not perfect, but you know, I do the best I can. What would this one be called? Well, because each base is a trapezoid, that would be a trapezoidal prism. Now, prisms are special because they have polygons as their bases. Polygon basically just means a 2D shape that has all sides, no curved portions. By contrast, a cylinder, right? Cylinder is kind of what happens when instead of having a polygon as a base, you have a circle, right? So here's a circle, and a cylinder is simply what happens when you allow that circle to be translated upward, right? So two parallel circular bases, and the circles have been moved vertically, right? Or if you have a kind of a flat ways cylinder, it can move horizontally as well. A cone is a little bit different, right? A cone happens when you have a circular base, but then you have this kind of like pointy part right here. We're going to talk about that later, but for right now, it's important to know that a cone has a circular base, but it kind of tapers to a point at the top, all right? Similarly, a pyramid, P-Y-R for pyramid, would have some kind of shape at the base. So this one's going to be a square pyramid, right? And the sides are all going to taper, right? They're all going to come and they're all going to meet at a point at the very top there. All right. Last but not least, we have one of my favorites, which is the sphere. Remember, we talked a little bit about what a sphere is. A sphere is just a set of points that's equidistant from a fixed point called the center, right? So here's the center of my sphere. Here's what's called the great circle, all right? The biggest circle inside that sphere. And then I'm just going to kind of draw my terrible approximation of what a sphere actually is, all right? So I know it's not great, but that would be a sphere. So if we go through very quickly, just down this list, numbers 1 through 12, let's just classify these shapes together so we can see what they would be. Number 1, rectangular pyramid. Number 2, cone. Number 3, triangular prism, because there are triangular bases and they rise upward, okay? Number 4 is a little tricky. Yes, it's a pyramid, but if you take a look, the base has 6 sides, so that's a hexagon, so we call it a hexagonal pyramid. Once again, number 4 is a hexagonal pyramid. Number 5, cylinder. Number 6 would be a rectangular prism. Number 7, trapezoidal prism, because what shape of the base is? Trapezoid. Number 8 would just be I think it's a square pyramid, because what's the shape of the base? It's a square. Number 9, what's the shape of the base? Because it has 5 sides. Well, it's a pentagon, right? So this would be a pentagonal prism. Once again, number 9, pentagonal prism. Number 10, it's a pyramid, but this time our base is a triangle, so it's going to be a triangular pyramid. Number 11 is going to be a triangular prism. Once again, that's a triangular prism because the bases are both triangles. And number 12 is going to be a sphere. I think that's pretty simple, right? Now, in the next video, we're going to take a look at what happens when we, excuse me. In the next video, we're going to take a look at what happens when we're asked to find surface area. All right, as a preview, that's what I call the wrapping paper problem, and we're just trying to figure out how much wrapping paper would you need in order to cover every single face of the figure. All right, so that'll be for next time, but hopefully you guys will have the basic idea of what each shape looks like, right? What is a prism, what's a cylinder, what's a cone, what's a pyramid, and what's a sphere. And then in the next couple of videos, we're going to look at how to apply surface area and later volume formulas to these, okay?